Hey everyone! Welcome back to part 2 of the Inclusive Math series. As you already know, in this series we're exploring some of the really not known but very useful tools and technologies that we have available to us in order to do math and science accessibly with the use of a screen reader. In part 1, we explored some of the basic prerequisites that we will be using throughout this playlist, especially in this video actually, in order to write said equations. And so to get started, I have my Word document open, as that is what we will be using for this tutorial. So the very first thing that we are going to start with, which is one of the slightly more advanced tools that we are utilizing, is the LaTeX autocorrect math editor that Microsoft Word 2019 introduced for us. What this basically is instead of inserting symbols into equations as you would normally do, sorry about that, on a Word document, what you do is you write the LaTeX code for it, and once you press space or enter, it autocorrects that into its actual symbolic representation. Now, LaTeX is basically a way that has been used for quite a while now, actually, quite a few years, to write math everywhere. It's a really known standard of writing mathematics. There's also other tools that are used to write maths with LaTeX, which we will be exploring later. But for this one, we will be using the built-in autocorrect that Word introduced, and it's pretty useful for those who intend to write maths and read it with a screen reader. Okay, so how we start, and also before we actually start writing these equations, this feature, as I said, was introduced in Microsoft Word 2019, which means that it is unfortunately limited to Office 2019. So for those of you who are using Microsoft 2016 or below, I urge you to look at updating your Office, and if not, then stay tuned for I keep pressing that button for whatever reason, but stay tuned for next upcoming parts where we will go through some of the other tools that are not built into Word but that can be used with Word, which work with whatever Office you're using. So anyways, let us get started with our very first symbol. So what you do to activate your equation editor, so to speak, is you hold down Alt and you press the equals sign when you're in a Word document. So I have a plain Word document open here. I just press Alt plus equals, and I'll play this again just to, not interrupt it this time. Selected. That basically it means that it activated an equation field. Yeah, so that's what it basically means.
Rate 55, rate 50. Rate 45, rate 40. Link equation baseline. Out of link equation page 1 baseline. Select out of link baseline blank unselected.
Yeah.
Link equation page 1 baseline selected.
So that's your equation. So here's where you can start typing.
Out of link baseline. Link equation page 1 baseline selected.
So say for instance I want to type the symbol alpha. So how we go about that? Alright. So the LaTeX symbol for alpha is the LaTeX representation, is \alpha. So if I type \A and if I press space now, like right now there's no change, it just looks like a bunch of gibberish, but if I have space here,
alpha, out of link baseline link equation page 1 baseline alpha,
there you go. It converted to its original symbolic representation, and it's also read by your screen reader. Now I am using NVDA for this, and in my experience, JAWS is better at reading these equations. It's slightly better, and it's more self-explanatory, whereas with NVDA you have to actually kind of get used to the way it says some of the things, and it's not super like self-explanatory when you first start out with it. but I got used to it, and I think it's not too hard to do so. But if you have JAWS, then I would recommend you use JAWS. But if you do not, then it's perfectly okay. If you're working with NVDA, it works just as well, and we will find out how in this video. Alright, so let's see.
Equation, comma, alpha, out of link baseline blank.
Yeah, so if I want to type more symbol, for example.
Link equation page 1 baseline alpha, out of link baseline
What
blank.
about beta?
Space, backslash, B, E, T, Z, Z, S, T, T, A.
Yeah, so as you might have guessed, backslash beta is beta. Once I hit space.
Space, link equation page 1 baseline data, baseline blank, baseline data, out of link baseline blank.
Yeah, so there's your beta symbol. Alright. So those are your basic symbols. I mean, there is a complete list that you can refer to, as you do need to use LaTeX code. I have a resource that I use to actually look up all these, and as I kept using them, I memorized them. But I will link to that resource in the video's description, so make sure to check that out. That's where you'll find all of these symbols in greater detail. So let's try to make a proper equation now.
Selected.
So I just hit Control A and backslash and got rid of the field entirely. But what if we want to type an equation now? Alright, let's see. Let's start out with our
backslash A L E A space
pal alpha. So we have alpha. Now what if I say
plus B E
beta
E B back B E T A space
beta
equals X.
Okay, cool. Let's hit enter. And let's hit up arrow.
Link equation page 1 baseline alpha plus beta equals X. Baseline link equation comma alpha plus beta equals X.
There you go.
Out of link end equation. Baseline blank.
There's your equation. Alpha plus beta equals X. Something similar we did in the previous part, except this is much prettier looking, and it's read better than it was before, where it was just plain text. Okay.
Alpha blank.
So without going into a lot of detail, as a lot of it is pretty much just exploring symbols as you go.
Selected.
And as you learn by looking at your resources, I will try to represent an equation with variables, as we did quite a lot of that before. Let's try something like
X plus Y dash Z equals C. Link equation page 1 baseline X plus Y minus Z equals C. Baseline blank.
Yeah, so as I said, it's much more self-explanatory. It says plus, minus, equals instead of plus dash. You know, it's better when you're listening to it.
X blank. Selected.
There's a few minor differences which I'll point out as we go along. Let's try another equation.
X plus Y dash C.
Actually, I'm gonna point out one of them right here, because I wanted to multiply something here. So if I want to multiply, for example, a to this equation, and now instead of typing star, which we usually did for multiply, just an asterisk operator, which is not what we want, we use another LaTeX code that we have for multiplication, which is times.
Backslash T I M E S space Z Z A equals C.
Okay, so let's see.
Link equation page 1 baseline X plus Y minus C times a dot equals C. X plus Y minus C a dot equals a dot C a dot equals C. Baseline blank.
Yeah, so though that is one of the few things, as I pointed out before, where NVDA has slight bugs that are actually being fixed as we speak. They will probably be resolved in the coming versions, but there's a bit of a misreading challenge there. But if you read it line by line, it reads just fine, like this.
Link equation page 1 baseline X plus Y minus C times a dot equals C. Baseline blank.
So it reads that, but if you try to read it char by char, it doesn't read the times where it should, and it just says A there. But like I said, I got used to it, and it's not as complicated. And in JAWS, if you have JAWS, then that's the best right now with maths. Okay, let's add something to this
X plus
equation.
Y minus C a dot equals.
All right, here before equals. If I wanted to add a power
Caret.
to this to B, So as we used before, the caret symbol, we used this for power before as well.
B.
Caret B.
Space.
All right.
Baseline
C.
blank. Link equation page 1 baseline x plus y minus c times a dot to the b equals c.
To
Baseline
the
blank.
B. Yep. To the B. That means it's, you know, the power. Again, much better than caret B, A caret B. But there's
Link x
it gets better.
plus y c time a dot n base b n superscript equals n superscript a dot to the b selected a dot to the b a dot n base b selected n base n superscript. 2.
What if I want to type 2?
Link equation x plus y minus c times a dot squared equals c.
A squared, so it doesn't say a to the 2. So it has a little bit of less redundancy with what it should say and what it shouldn't, in order to make it easier for us to read. Okay.
X blank.
Nice.
Baseline blank.
Now we want to get into something that, as I said, was
Selected.
very important to learn in the previous part, which are brackets. Okay, let's do a little bit of that. What if I want to represent a fraction? Let's try that.
X plus B slash
on
C.
C.
Space.
If I read this,
Link equation page 1 baseline x plus b over c. Baseline blank.
x plus b over c. So as I pointed out in the previous part, if we don't put brackets, that's what it's going to look like, and that's what that's what Microsoft Word considers as well. If you don't use brackets, then it's going to give you the denominator as below whatever you type before the slash symbol, without brackets. So let's try to read this now.
Link equation x plus fraction b and numerator c and denominator out of link and equation. Baseline blank.
Yes. So that's as expected. B is the
Link
denominator.
equation page 1 baseline x plus b over c. Baseline blank.
C is the denominator of B. Okay. Now I encourage you to pause this video and think about how we could go about representing the whole x plus b as a numerator. We discussed this before in the blog post as well as the previous video, as how we would go about doing that. So think about it for a second, and then we'll discuss this and break it down together. Alright, so as we discussed before, here's where brackets come in. These really handy things that we
x plus b over
use.
baseline blank. X plus link x blank.
So if I retype this
Selected.
equation, let's say
Left parent x plus b right parent slash
over C.
space
Take
baseline.
a listen to this now.
Link equation page 1 baseline numerator comma x plus b and numerator comma over c. Baseline blank.
There we go. X plus numerator, x plus b over c. There we go.
Link equation
Let's
comma
read this chart
baseline
by
blank. Link
chart
equation fraction x plus b and numerator c and denominator.
There we
Baseline
go.
blank.
Now it actually knows that x plus b is the numerator, whereas c is the denominator. And we can go a step further.
New blank. Selected. Left parent x plus b right parent slash left parent c plus d right parent space.
And do the following.
Link equation page 1 baseline numerator comma x plus d and numerator comma over denominator comma c plus d and denominator. Equation comma fraction x plus b and numerate c plus d and denominator out of link and equation. Baseline blank.
There we are. So much better than before, right? I hope it looks prettier as well. This is the what I have personally been using with my school and everything else to do maths and sciences. So it reads it out much better than before, where it would just say x plus b slash whatever b plus c, and it also looks better in this equation field, where it's written as it would be for any sighted person, maybe inserting those symbols or writing it in their own formats. But it's just it's doing the exact same thing, but it just recognizes another form of pattern that we use, which is LaTeX, as I pointed out before. So we're doing the exact same thing as inserting the symbols, except we're not inserting them, we're just typing them out. So as you'll notice, if I
selected
open this, you can also those people who can actually see the screen will notice there's symbols appearing in this equation field that they can actually insert. And if you hover your mouse over, for example, if there's a symbol, this tip actually comes in it really comes in handy, because it is possible that there are a couple symbols that are not available in that resource that I will be linking down below. So if there are any symbols that are not there and that you are in need of, if there's a sighted person that you have around, please take a look at your screens once this equation field is open, which you of course do it by pressing Alt equals, and you make it disappear by pressing
Equals.
the
Equal. Z.
same.
Blank.
Um,
Selected.
But a list of symbols should appear, and if you just hover your mouse over that symbol, to all the people who are using a screen reader, it'll read the symbol name as well as its LaTeX code. So if it's alpha, it'll say alpha and then \ALPHA if the mouse is over that symbol. So that also gives you an idea of how to write it. This is just a tip that really comes in handy. So let's try typing a really long equation and see what that looks like before we actually end with this part. Okay, let's see. I want to say
X, left bracket. 2. Caret. 3, left brace. Y. Plus. 8, left parent. 1. 1. 1. Dash. Backslash SQRT. Space. 4. Right parent. Slash. Left parent. 1. Plus. Space. Backslash SQRT. 4. Right parent. Right brace. Right bracket. Space. Link equation page 1 baseline x open bracket 2 to the 3 open brace y plus 8 open parent 1 minus square root of 4 comma closed parent over denominator comma 1 plus square root of 4 and denominator comma closed brace comma closed bracket. Baseline blank.
a really big equation right there. Yeah, so let's go over this character by character.
Link equation x open bracket superscript 2 and base 3 open brace y plus fraction 8 open parent 1 minus square root of 4 and root closed parent and numerator 1 plus square root of 4 and root and denominator closed brace and superscript closed bracket out of link end equation. Baseline blank.
So yeah, there we go.
Blank.
So this is a fairly large equation, and as you can see, it read it out just fine. Everything, all the powers and square roots. It might have slight quirks which are actually read better by JAWS that actually help you identify, because for when you're actually writing these first, especially if you're doing complex equations, you will be making mistakes. It's pretty natural to go wrong here, because there are certain things that you have to get used to that are not really explicitly explained. So things such as when if you type 2 to the power of 3 and then if you type 4 after that, it might also take that 4 in that power unless you use a bracket. And so where to use brackets, where not to use brackets, where to have a separate equation field for two different expressions. These are the things that you actually catch on to as you start working on this equation, which is why I encourage you to have take help of someone who's sighted and who's looking at your screen, and to just make sure that what is it writing what you intended to write. So that's basically all that you need with those resources and a lot of practice. I think it is pretty doable to with this LaTeX editor in Word to do math and science. Alright, so I hope this video was proved to be useful. And if there are any questions, of course, as always, feel free to comment down below. I will try my best to answer. And I didn't point out in the previous video, sorry about that, but there will also be a text tutorial that I will put up soon on the blog as well as this video. So if you prefer reading and want just a quick skim through all the content that's covered here, that will be useful for you. As always, I'll be linking other resources that I find, in this case the LaTeX repository in the description, which you can look at and refer that to type your equations. and slowly you'll start memorizing them. You'll pick up on them as they're not really not that hard. It's pretty much mostly is the same word or a shortened form of that word. For example, square root is SQRT, but alpha is ALPHA. So it's pretty easy to pick up. Once that's done, just keep looking, keep having someone who can see the screen look at your computer and see if you're writing what you intend on writing, and soon enough you'll get a lot better at it and be able to use it mainstream, which I have done, and it works fortunately quite well. Alright, so that's all for this video. Once again, you need Office 2019, JAWS if you have it, otherwise NVDA works, and that's pretty much all you need for this to work. I hope you learned a lot from this video, and feedback is always welcome. Do drop a like if you like it, and share it with your friends. I hope this comes in handy for people who are looking for such resources. But I will see you all in the next part, where we dive a bit more into LaTeX and what it's used for, with some external tools that do not specifically are not connected to Word. Anyways, I will see you next time. Stay safe, stay inclusive.